elementary video project is dimensional analysis. So the official definition of dimensional analysis is basically describing the relationships between different physical quantities, and you do this by identifying their fundamental dimensions such as length, time, mass, and their electron charge. You also identify their units of measure such as miles versus kilometers, pounds versus kilograms versus grams, things like that. And by tracking these dimensions, you track them as calculations or comparisons as those are performed. But the basic definition that I like to think of is basically from getting from one place to another. I think the easiest way to kind of explain dimensional analysis is just by doing a few examples. So the first example is a very simple one. I'm going to do 3, and they get a little more in depth as they go on. But the first one's very simple, just to kind of get the basic bones of dimensional analysis. So we are going to be converting 256 grams to kilograms. So another very important thing for dimensional analysis that you can't do dimensional analysis without is unit conversions. And unit conversions are either given to us or it's things that we know that relate one thing to another. So, for example, from grams to kilograms, we know that there are 1,000 grams for every 1 kilogram. That's the only unit conversion we need because that tackles both that were given. So, since we know there's 1 kilogram for every 1,000 grams, we can write that to the side so that we remember it. And then you always want to start with what you're given. So we're given 256 grams. We want to get that to kilograms. So you kind of just set it up as multiplication and division. So I plug in my unit conversion. And you want to make sure they cancel out. So if you looked at this, like it was over 1, then you would want to put grams on the bottom so that they cancel out, and 1 kilogram on the top. And then you just go across like multiplication and division. And when you type this into the calculator, you'll end up with 0.256 kilograms. That one is very, very, very basic. But that is dimensional analysis. The next one is a little trickier because it's dealing with units of time and length at the same time. So you have to convert all of them. So in this problem, we're going to be changing the speed from 72.4 miles per hour to meters per second. So first we want to see what in the problem, what unit conversions does it give us in the problem. So the only one it gives us in here is we know that there are 72.4 miles for every 1 hour. So now what we want to do is try and figure out how we can get from miles per hour to meters per second. So we have to think of things that we are just supposed to know, the basic conversions that we're all supposed to know and memorize. So for instance, we know that to get from miles to meters, we're going to have to go down. So we know that there, for every 1 mile, we have 1,760 yards. But we got to keep going, smaller to meters. So we also know for every 1 yard, we have 36 inches. And then to get to meters, we know there are 39 inches for every 1 meter. But we also have to think about our time. Now our time is easier because we're just going from hours to seconds, and that can be dealt with in 1 unit conversion. So again, remembering that this is over 1, we need our hours to be on the top. So we have 1 hour to 3,600 seconds. And that right there is our problem. And we can check it because we know miles cancels out, yards, inches, Meters doesn't have anything to cancel out with, which is good because that's what we want to be left with. And then our hours cancel out. So we'll be left with meters per second. So now, if you type that in across, you're going to end up with 32.7 meters per second. So this next one is a little bit longer and it's more of a word problem. So the good thing about word problems is most times it's going to give you more unit conversions. So this example is, what would it cost to send a rocket to Mars, which is 7.9 times 10 to the 7th kilometers away from Earth, if the average speed of the rocket is 1,600 miles per minute and the solid propellant consumption averages 125 grams every 1.5 seconds and cost $775 per pound. So that's a lot, and at first that can be very intimidating. But what you want to do is just go through. So if we read this problem again, we know that for every 1,600 miles, you get 1 minute. So there's our first unit conversion. And then if you keep reading, the solid propellant consumption averages 125 grams every 1.5 seconds. So there's our next one. And then if you keep reading, it also costs $775 per pound. So this one's interesting because it's dealing with units of length, time, weight, and money. So it's a lot, but if you use unit conversions, you can get there very simply. So once again, those are the ones that were given. Now, what is our starting point? And that is basically, what would it cost to send a rocket to Mars, which is 7.9 times 10 to the 7th kilometers away? So that's what we start with. So we start 7.9 times 10 to the 7th kilometers. So that's what we start with. Now, we know, looking at our unit conversions, we don't have anything that deals with kilometers, so we can't just plug in a unit conversion. But we can look and see, what do we have? Now, this one's grams and seconds, so that's not kilometers. And this one is money and pounds, and that's not kilometers either. But this one has miles in it, and miles has a relationship to kilometers. So we plug in that relationship. For every 1 mile, there are 1.61 kilometers. And now we have miles. So we can use our first unit conversion. So for every 1 minute, there's 1,600 miles. So we can cancel this one out because we used it. Now, once again, we have minutes now, but we don't have any minutes in our unit conversions up here that were given. But we do have seconds, and seconds has a relationship to minutes. So we can first say that for every 1 minute, there are 60 seconds. And now that we have seconds, we can use our next unit conversion. Make it a little more clear. Okay, so we can cross that one out because we used it. Now we have grams and seconds, and we have pounds and money. So what we want to do next is find out the relationship between grams and pounds. So we know that for every 1 pound, there are 454 grams. Now that we have grams, or now that we have pounds, we can use our last unit conversion. For every 1 pound, there's $775. Now, we've used our last unit conversion, so we can go through and check, does everything cancel out to where I am left with money per pound, because that's what it's asking. Or it's asking for the cost, so we need to be left with just the money. So if we go through, my kilometers cancels out, my miles cancels out, my minutes cancel out, my seconds cancel out, grams, pound, and all we are left with is money, which is what they want to know. If you type all of this into the calculator, you are left with 2,061,000, or 261,756,265.90. So we started with all of these different units and ended up with just money. And it was as simple as that. So basically, dimensional analysis, the main thing to do is start with what you're given, then figure out what unit conversions you're given in the problem. Then from that, you need to go with the things that you know and just see the relationship. Dimensional analysis is all about relationships between one thing to another to end up with what you want. Thank you.